Hi guys, I'm Jerry, and after the 2015 GCSE higher paper of the mathematics exam, there are a lot of discussion around concerning two questions within it. One is about Hannah's candies, and the other is the filling canister. And so I'm here to do a question breakdown on those two questions that have been considered impossible. So after that exam, right away, there are people, students that sets the exam, posting question on the Twitter, Facebook, and a lot of other social media sites, saying that they are really frustrated about that question on the paper, and it just makes everyone agree that it is really difficult. And from a post, it's even says roughly 90% of the country don't know how to do this question, which, to be fair, that is an exaggeration. So I'm sure that people can do better than that, and I'm here to do a breakdown on every single aspect you need to know about those two questions. So this question has appeared on the Telegraph, on the internet, on news. So basically, that means this Hannah's sweet question, it's pretty much an agreed difficult question. And down here it gives a comparison of Cheryl's birthday in Singapore, compared with Hannah's candies question, which, to be fair, I think it's a big exaggeration. Hannah's candies are much easier to answer compared to Cheryl's birthday because there are much less logic required. And down here, it pretty much shows how frustrated students are, especially this sentence. Well, that escalated quickly. So yeah, let's start on breaking down this difficult question. So let's start with Hannah's candies. Hannah had a bag containing N sweets, 6 of which are orange. She took one and ate it, then she took another one and did the same. And the chance it's given that her chance of taking 2 orange sweet is 1/3. And if I'm right, the Telegraph statement yellow sweet is wrong. So just so it's clear, it's just one color and not color, basically. So it's the N sweets, 6 are orange or any other color, then the 1/3 chance is all it gave you in this particular question. And those are the 3 key pieces of information that's given. Then, as that statement clearly shown, that escalates to a apparently clueless proof that n squared minus n minus 90 equals 0, which to a lot of people it's just frustration because it's, 3 sets of data means a proof. How can that be? So yeah, let's jump into that question right away. So in this question, you've got 3 key informations: N number of sweets, 6 orange sweets, and 1/3 chance. So these 3 can be put aside for now. I want you to think about official representation of that question. So I've created a drawing, quite poorly drawn, so bear with. That is the official representation of that particular question. So need to put a 6 there. So there are six orange sweets, n number of total sweets. We don't care what color they are because it's out of the question. So now Hannah took 2 sweets. I will represent it with red color. So first of all, it takes 1 sweet out, which can be either orange sweet or random sweet. Okay, so she got 1, which is orange, and so let me draw that out. So now we need to think about what happens at this instance, because it's given that each sweet is taken out 1 time by another time without putting back into the bag. So the chances of Hannah taking an orange sweet is 6 out of n. Okay, so that is the first representation, and I indeed made it 6 as orange because it's the orange sweet, so it's more clear. So 6 over n amount of probability that she'll get an orange sweet out. Okay, that is the first draw. For the second draw, she did the exact same thing. She took another candy out. Remember, this candy is discarded or eaten. So did this one, because basically you remove 1 orange from the bag and you remove 1 from the list. It's basically what happens. Then we've got 1 sweet eliminated from the draw, so this 6 becomes 6 minus 1, which is 5. In black, please. So in 5, nope. Gosh. Yep, so it turned into 5, and n turned into n minus 1 because the total number of candy reduced. So now we have, after we change all those values, we have a different probability of getting an orange sweet. So because there are only 5 orange sweets now, there are 5 over n minus 1 probability of getting an orange sweet the second time around. So now we have 2 probability and a final probability. That is what we can find from these 3 raw information. So let me clear the page. Okay, so now with a cleaner page, we have the first possibility, the probability of getting first orange, and the second probability of getting an orange sweet. So if these 2 combine together, it will form the last, which is the final probability. So we can basically draw an equation based on what we have as information states, and the fact is that you have to multiply 2 probability if it's consequence, which is a AND. If it's OR, you add them. So now it's apparently an AND. So we multiply these 2 values to give 1/3. That is true for all probability. And so we have, from those 3 raw data, created an equation. And what they want us to prove is also an equation equals 0. So now what we need to do is to simplify this whole equation. The first thing I suggest you to do is to multiply these two together into one big thing, which is, if you're quick, 30 over n squared minus n. If you are quick, that is. If you're slow, you can do it slowly, doesn't matter. It's just a fact that you know how to simplify this big fraction is enough. So what we know now is that 30 over n squared minus n is equal to 1/3. So we've got those handled, and next up we need to simplify those two sides, which there is a great way of doing it, the cross method. And the cross method basically means the bottom left multiply the top left, the top left might multiply by the bottom right. Did I say top right here or top left? Doesn't matter. It's just cross. This is the cross, and that is the method of doing equations. And you can basically draw that 3 times 30 in black. 3 times 30 is equal to 1 times n squared minus n, which is n squared minus n. So now we have yet another equation from this rearranging. So this equation is much easier to understand, is it? So what you can do is now to get 3 times 30 equals 90 equals, I'm just gonna copy and paste to save me some time. Typewriting is not easy on computer, and so we can subtract both sides by 90 to create that the answer, but it's the other way around. So it's basically 0 equals n squared minus n minus 90. If you subtract both sides by 90, that is. So that is the equivalent of n squared minus n minus 90 is equal 0. So this is the way to do this Hannah's candy question. And the second part to this question is basically to solve this equation, which you can either use the quadratic formula or to factorize the equation. So basically you have two brackets that equals to 0, and that would be minus 10 and plus 9. That is my quick calculation after messing with this question. So we've got these two, and the possible way of getting 0 is either bracket is equal to 0. So if n minus 10 is equal to 0, then n will be equal to 10, because 10 minus 10 equals 0. Or n plus 9 equals 0, which means that n is negative 9, because 9 minus 9 is equal to 0. So now we have two possible answers for n, and you can put either into the answer. No, you can't, because this is a candy question. There aren't a thing called negative 9 candies. So remember, if you see a negative 9 in, well, and a negative number in any like distance, any object numbers, like object counts, or any countable things, cross it. Well, that's cross it. Just remove it from existence. We don't care about it. So the correct answer for for the sorry, I got interrupted there. So the correct answer for this Hannah's candy question is n equals 10. This is how you solve the answer. So that is it for this question. So second question, the filling canister. Well, it's not really a canister, but deal with it. This is my way of explaining this question. So according to what I've heard, I've created this diagram, and the question states that a tap is turned on to fill the canister. At 5 hours, the height of the water or any substance is 6 meters. Because I don't actually get the question itself, I just know that something's filling it, so I use water instead. Then at 9 hours, the canister fills completely, and you want to find h as the height of the cylinder. The radius is 3 meters, the cylinder is h meters high, and the cone under it is 4 meters high. So that is all you get for this question. So the key fact is that 3 meters as a radius, they share the same face, the same circular face, so they have the same radius. We need to find h, and we have 4 as the height of the cone. So basically, we can find the volume of that particular cone shape, but not the cylinder. At 5 hours, the height of water is 6 meters. That is another clue, 6 meters. And at 9 hours, it fills completely. So it fills up 4 plus h meters. So we need to find h. And remember, this is non-calculated question, and you have to give the answer as a fraction. So for this question, you need to understand that the fact that water fills from bottom to the top means that you can get a certain height of the cylinder out of the first clue. The first clue being after 5 hours, the water reaches 6 meters high. So that if you combine these information, you can say quite confidently that at 5 hours, the canister that is filled is this diagram, given that the height of the cylinder is 2 meters, the height of the cone is still 4 meters. This is the filled volume of the shape or the canister, and you can say that is true because 2 meters plus 4 meters is equal to the 6 meters given. So there is another cylinder up here that is hidden so that you don't get confused. So now, given that, we can start to work out what volume is filling the canister, or the rate of the tap giving out water. So what we need to do now is to find the volume of the cylinder, which is given as base area, which is the circle, given that the base area is equal to 3 squared times pi. Wait a minute, I need to get the command for pi. Okay, I'm back. It's 03C0 and alternate x. Yeah, there we go. So I've got a pi here, and the base area is equal to 3 square pi, which is equivalent to 9 pi. You don't need to know that command kind of thing. I'm just typing it out so that it's easier to understand. So we've got a base area of 9 pi meter squared, which you really don't need the you don't need the unit for it because it's gonna cancel out each other anyway. So now we've got the base area. What you need to know about a base area is basically I need to change my font back to the correct one, which is this one. There we go. To get the area of a cylinder, you need to times the height times the base area by the height, which is 2. So basically it's 9 pi. Nope. This is just ridiculous. I'm gonna go copy and paste mode. Yep, much faster. 9 pi times 2 is equal to the cylinder. Then we need to add the bottom part, and who knows, the bottom part of cone, like the air, the volume of the cone, who knows? Well, you can do it quite easily. There is in the front part the equation sheet that you can use, which gives you clearly 1 divided by 3, which is 1 over 3, times the base area, which is 9 pi, which I'll add later, times the height, is equal to the volume of the shape. Yep. So here you have it. And what you need to do now is to simplify all of them to get the volume, which I'll say it's 18 pi plus 1/3 of 9 is 3 times 4 is 12 pi, and that would be in beautiful way think. So that would be a factorized way of representing this simplification, which will eventually become 30 pi. Oh, I hate these symbols. Okay, so now we have 30 pi as the volume of this filled whatever. So now we need to find the rate of water going into the cylinder or the canister. So it took them 5 hours to fill this volume. So 5 hours for 30 pi. Okay. So 5 hours S. Okay, sorry. 5 hours for 30 pi. That is for each hour how much water is being filled in. So we need to divide the volume by the time, so we can get actually the 6 pi amount of water for each hour, and that is obviously out of the picture. For each hour there's 6 pi. Goodness. Yep. So we've got 6 pi volume for each hour. This is the rate, which is really important. This is the thing that we need to have a backup of, because I'm going to clean this page and finish this question. So now we have worked out the rate of water going into the cylinder. This rate is constant, given the question didn't say anything special about it. So it took 9 hours to completely fill this specific shape. So for 9 hours, it have a volume of 9 times 6 pi, 9 times rate, which is 54 pi. Let me select pi. Oh, sorry. Yep, so it's got 54 pi as the volume, and we need to find the height of this particular thing, and we do know that the base area is 9 pi, which we've calculated obviously. So we can this is the total volume of this shape. We need to subtract this cone shape. So the cone shape will be again 1/3 times 9 pi times 4, which is again 12 pi. Here we have it, 12 pi, which is we now subtract that 12 pi from the 54 pi, so we basically have this big volume, subtract the bottom part to get the top part. So now we can pretty confidently say that the volume of that the cylinder is 42 pi. Here we go. So 42 pi for the cylinder. I might as well write it out. Cylinder is 42 pi. So now we have the base area, we have the volume, we don't have the height. How should we get the height? Well, you divide the volume by the base area to get the height. So it's 42 pi divided by 9 pi, which the pi cancels each other out. And if you really want me to do it, I'm gonna just I'm just gonna do this and cross it out right away, so it's no big deal. Yeah, so basically you remove the pi from each other, then 42 divided by 9. How do you do that? Well, we know that 9 times 6 is 54, 9 times 5 is 46, kind of thing. No, 45 rather. So it's probably 4 is the closest answer that you can get. So 4 is the whole number that you want. So 4 times 9 is 36. So we need to do 42 minus 36 to get the remainder. The remainder is 6. So we have got 6 over 9. And if you're intelligent enough, that you should be noticing that you can actually cross things out here. So 6 will become 2, 9 will become 3. So basically you have the answer 4 and 2/3. And that is the answer to the second question in the GCSE higher mathematics paper. And again, everything is done on screen without calculator. I just rambled everything through. Took me 13 minutes to explain every single thing, which is a notable well, yeah, I've put a lot of effort here, so I hope you now understand the questions better. I wish you a very, very best luck in tomorrow's calculator paper, and I really hope that these kind of questions don't come up, because it's quite mean. And yeah, I hope that you guys enjoyed. If you do, leave me a like. Helps me out a lot, and I will see you next time.